Good morning, everyone. We are here to present our final project on the topic a coupled approach to sentiment analysis. We've done our project in collaboration with Indian Space Research Organization LPSC section. We worked on this to develop an AI chatbot with the ability to have facial, emotional, and sentimental recognition capabilities. Our chatbot is developed to converse with astronauts in space travels and be an emotional companion for them. It has the ability to recognize facial expressions from faces and analyze the sentiment of the sentence from the chat and reply accordingly. Our basic block diagram is consisting of the user inputting a text sentence while being tracked by a video stream. The video stream goes through FaceNet model and an AI HTML5 SDK. Meanwhile, the text input goes through the BERT model, and these two outputs are compared to give out a reply of our chatbot. When talking about the facial recognition model, the facial recognition works by detecting, analyzing, and finding a matching pair with already trained data. We use the FaceNet model, which extracts face embeddings or face data to train the model. We trained our model on a custom dataset consisting of 291 colored images of 6 Bollywood celebrities. Emotion recognizes prime job is to identify different emotions in the human face and categorize them into positive and negative. Emotion recognition is employed using face API.js, a JavaScript API for the task of face recognition in the browser alongside TensorFlow.js. Deep learning models are run under the hood using WebDNN library as the engine. We later switched to Morphcast AI HTML5 SDK as it runs slightly faster and accurately than Face API.js model. It fires events at a rate up to 30 per second. It runs on similar technology as the Face API.js framework. The third segment of our project is Sentiment Analyzer, which classifies the underlying sentiment of a given input sentence. A common problem faced here is the lack of facial expression and voice modulation that makes it even more challenging to correctly determine the emotions of the user. The proposed model aims to rectify the shortcomings by including facial cues from the user while analyzing the textual feedback. We have used BERT for processing our text data. It is a language model that runs on encoder part of the transformer. It has been executed using a trained module under TensorFlow Keras in Python. Our project requires a basic level of chatbot which has to be integrated with our sentiment analyzer and emotional recognition model. The development of the chatbot was a difficult task since the priority was to hold an empathetic conversation. We developed the emotional recognition model using JavaScript and it hosted on the local server. There is a deep neural network running under the hood which takes in the live video stream from the webcam and gives three input output variables. The first one is the number of detected faces in a given frame. The second one is the status of the model, and the third, the emotion of the user. We are getting a constant output of 30 frames per second after processing the live video stream from the webcam. This is how the output from the sentiment analyzer model looks like when a set of inputs are given. It returns the sentiment and confidence of the model. This is the result we obtained after the model evaluation. The model performs really well with an accuracy of 0.97. We had retrained the Blender bot using empathetic dialogues, a novel dataset consisting of almost 25,000 conversations. This is the output of the chatbot when it runs independently. When we used conditional statements inside the code to run modules as per our needs, we faced the issue of all modules being called sequentially in order, which is just the opposite of what we were planning to implement. So we used the concept of multi-threading to run all modules simultaneously. We also assigned timestamps to output to cross-check the emotion of the text sentiment. We use a library in Python called eel to start a server and host the JavaScript on it, which enabled data transfer between JavaScript code and the Python code. The user inputs are processed by the sentiment analyzer model and then passed to the chatbot. It also cross-checked with the emotion detection model before passing to the chatbot. We also build a front end where the user can interact with the chatbot like they do in a normal chat room. The chatbot we developed has four main modules, which are face recognition model, emotion recognition module, and the sentiment analyzer and the chatbot module. all the modules are working just fine independently. Some of the integration part is already done. Thank you for watching.